In this video, we'll be talking about polynomial functions. Remember that a polynomial is an algebraic expression that consists of sums of powers of a variable. And so a polynomial function is basically a function whose formula for determining the output is a polynomial using the input variable. Now, before we go over the formal definition, let's take a look at some examples of polynomial functions. Our first example of a polynomial function is f of x equals x to the fourth plus 5x squared minus 3x plus 4. This is a polynomial function because the formula that we use to get the output is a polynomial, meaning it consists of sums of powers of x. We have x to the fourth power plus some multiple of x squared plus some multiple of x to the first power, and then the 4 at the end, that can be thought of as 4 times x to the 0th power. Another example of a polynomial function would be something like g of x equals negative 2x to the 7th power plus 1/3 times x to the 4th power minus 6x plus 5. Again, this is a polynomial function because the formula to compute the output consists of sums of powers of x. We have some multiple of x to the 7th plus some multiple of x to the 4th plus some multiple of x to the first power plus 5, and this plus 5 can be thought of as 5 times x to the 0th power. One last example of a polynomial function would be something like h of x equals 5x cubed times x minus 4 times 2x plus 1. This time, it's less obvious that this is a polynomial function because the right-hand sum isn't written as sums of different powers of x. Instead, what we have is a product of different polynomials. We have 5x cubed times the polynomial x minus 4 times the polynomial 2x plus 1. But one thing you might remember from algebra is that if you have a product of polynomials, the result is still a polynomial. Now that we have a rough idea of what a polynomial function is, let's talk about the formal definition. A polynomial function is a function of the form f of x equals a sub n times x to the nth power plus a sub n minus 1 times x to the n minus 1 summed up through a sub 1 times x plus a sub 0. In our expression here, the x is our input variable, whereas the a's are constant multiples, meaning they have a fixed value. So this a0, a1, a sub n minus 1, a sub n, they all have a fixed value. These constant multiples are what we call the coefficients of the polynomial. We use the subscripts 0, 1, n minus 1, and n to indicate which power of x our constant is multiplied to. One thing to note about polynomial functions is that the powers of x are always non-negative integers. So you'll never have a negative exponent or a fractional exponent. When we look at the different powers of x that are in our polynomial, the highest power of x is called the degree of the polynomial. And lastly, we call the term that contains that largest power of x the leading term of the polynomial. And you'll also hear the coefficient of that leading term referred to as the leading coefficient. Now, let's go back to our examples of polynomial functions that we had in the beginning and try to identify the degree of the polynomial function and also the leading term. In example A, we had f of x equals x to the fourth plus 5x squared minus 3x plus 4. The highest power of x that's present is 4, so the degree of the polynomial is 4. And the term that contains the highest power of x is x to the fourth power, so that is our leading term. We would also say that the leading coefficient here is 1 because there's no specific number written out in front, so we can think about this as 1 times x to the fourth power. For example B, we had the function g of x equals negative 2x to the 7th plus 1/3 x to the 4th minus 6x plus 5. The largest power of x that's present here is 7, so the degree of this polynomial function is 7. The term that contains this largest power is negative 2x to the 7th power. So that is our leading term. This time we would say that our leading coefficient is negative 2 because that's what's being multiplied to x to the 7th. For example C, we have h of x equals 5x cubed times x minus 4 times 2x plus 1. At the moment, it's a little bit difficult to identify the degree and the leading term because our polynomial is not written out as sums of powers of x. So first, we'll need to multiply out the polynomial so that it is a sum of different powers of x. To do that, I would start by multiplying out x minus 4 times 2x plus 1. We can multiply that out using the FOIL method. So first, let's write down the 5x cubed that's out in front. And then if we multiply out x minus 4 times 2x plus 1, first let's multiply the first terms. The x times the 2x gives us a 2x squared. If we multiply out the outer terms, we have x times 1, which is just x. Multiplying out the inner terms, we have negative 4 times 2x, which gives us negative 8x. So combining the outer term with the inner terms, we have x minus 8x, which gives us negative 7x. And then when we multiply out the last terms, we have negative 4 times 1, which gives us negative 4. Now that we've multiplied out x minus 4 times 2x plus 1, what we can do is distribute the 5x cubed to get our final result. So take that, multiply it to each of our terms here. We're going to get 10x to the 5th minus 35x to the 4th minus 20x cubed. Now that we have our polynomial multiplied out, we can identify the degree and the leading term. The highest power of x that's present is 5, so that's the degree of our polynomial, and the leading term would be 10x to the 5th. And so for this polynomial, the leading coefficient would just be the number 10. Now, one thing to remember is that when you have a factored polynomial and you want to multiply it out, each term of each factor gets multiplied together. So a quick way to determine the leading term of a polynomial is to multiply together the leading term of each of the factors. In our example here, the factors are 5x cubed, x minus 4, and 2x plus 1. If I want to find the leading term here, I can multiply together the leading term of the first factor, which is 5x cubed, with the leading term of the second factor, which is x, and with the leading term of the third factor, which is 2x. Multiplying together 5x cubed times x times 2x gives us this 10x to the 5th power. So when you're trying to determine the leading term of a factored polynomial, you don't need to multiply everything out, you just need to multiply the leading terms in each of the factors. So in this video, we learned what a polynomial function is, and we learned how to identify the degree of the polynomial and the leading term of the polynomial.